This is Algebra 2, Chapter 0, Section 7, in which we will study congruent and similar figures. Congruent figures are identical to each other. They're the same shape, same size. In mathematical terms, we would say that all of their corresponding angles are equal and all of their corresponding sides are equal. Now, the order of the vertices matters, because the order tells you which one corresponds to which. So we need to figure out the right order for our second triangle over here. We picked ABC for the first one. First one you can pick any way you want to, then the second one has to match. A is marked with the single mark. Which angle over here is marked with the single mark? E. B is marked with 2 marks, so it must go with D, which has 2 marks. And then C and F each have 3. So ABC is congruent to EDF. And this is the symbol for congruent. Equals with a little squiggle on it. Now, congruent by itself isn't very interesting. But similar has a lot of use to it. When we say figures are similar, they have the same shape, but different sizes. Okay, you can think of it as taking it to the copier and doing an enlargement or a reduction. You tell it to go to 80% the size of the shape you had, and it makes it smaller. You tell it 125%, it makes it bigger. Okay. Now, just like with congruent figures, the order of the letters matter. So again, we have triangle ABC. We need to decide the order for this triangle. And we go by who matches who. A matches F, because they each have 1. B matches E, because they're both marked with 2. And C matches D. Now we say they share a common ratio. Let's look at what that's talking about. The ratio of AB to FE. AB is the first pairing, so FE is the first pairing. What does that reduce to? 2/3. Let's try A to C and F to D. AC is 6, FD is 9. And that reduces to 2/3. Then we have one more pair to look at, BC and ED. 8 and 12 also reduces to 2/3. Since the ratio is the same each time, they all reduce to 2/3, then that proves that they're similar. More what you're going to be interested in is figuring out information based on similar figures. So let's say, for the sake of argument, the state of Minnesota has decided to build a bridge across Lake Elysian. And they give us this beautiful diagram for us to figure out the distance across. Okay, and I just kind of picked numbers, so it may or may not work out to be right. Now, if you see carefully here, you see one triangle, and then you see another triangle. I'm going to separate those triangles out to make it easier to understand what I'm looking at. Okay. We split the 2 triangles apart. Notice AD is 12 all the way across here. This part is 3, and this part is 9, so the total is 12. That's the most common mistake people make. They just want to bring this 9 over. But it's not 9 there, it's 12. Now we can set up ratios. 12 is to 3 as x is to 2. Well, now we're in business. We know how to cross multiply. 3x equals 24, or x equals 8 miles. So according to this, it would be 8 miles across the lake. May or may not be accurate, but that's what we came out with from the arithmetic. So you'll be working with identifying congruent figures, identifying similar figures, getting the orders right for the names, and then you'll be doing some of these kinds of problems with cross multiplying and setting up your ratios. So hopefully, as always, if you had questions, I hope you wrote those down, and we will see you in class.